Okay. So I will tell you today about Bootstrap and Cuis dynamic libraries. I want to start by thanking you all for being here today and the UK Smalltalk user group for hosting these meetings. This presentation today is about a major project in an ongoing effort to make Cuis meet the needs of commercial projects like those developed at Labware. So thank you, Labware, for sponsoring this project. This presentation will include some material that was shown by Felipe Sack and me at the Smalltalks conference in Quilmes in Argentina in November 2023. So these are some of the objectives we set for this project. We want to build Smalltalk images from scratch. We want to start with an explicit list of what should be included in the new image, ideally a set of source code files. The code in the image being built needs to be independent of the code in the builder image. There is no mother image or such, and the builder must be easy to extend to new image formats. With respect to libraries, we want binary code libraries that don't require source code and won't use a compiler to load. We also want to be able to load libraries that define possibly different class shapes for classes that already exist in the loading image or in another library that was previously loaded. Library loading should almost never fail, and we want to be able to load tons of libraries quickly. So for this kind of functionality, there is some technical challenges. We want our new image and compiled libraries to include classes and methods, and also some collections. If we simply load these classes, methods, and objects into a builder image, there are several possible problems. Our classes and methods may clash with stuff that is already in the image, having possibly different class shapes and method code. All references are valid in the image, in this builder image, but most likely not in the image we're building. Class shapes for basic objects such as method dictionary, system dictionary, or even string could be different. And the values and even the bit size of identity hash could be very different. For these reasons, including in the builder image the code and state that is intended for the new image would mean having to carefully untangle and transform these objects as they are serialized into a new image. And similar problems will happen with libraries. So the code performing this task is deeply involved with both the current and the new image format, shapes of basic classes, and details of hashing. So this code tends to be complex and hard to evolve. So we did something different. The strategy chosen was, instead of loading the code in the builder image, build a separate Smalltalk model for it. These class shapes are not classes. They cannot create instances. These method specs are not compiled methods. They cannot be run, but they can be materialized into actual classes and methods. For other objects to be included in the new image, instead of, for example, creating a new instance of system dictionary or as many method dictionaries, we create instances of a foreign object hierarchy. This, together with an appropriate image builder class that is specific to one image format, can be serialized to save a new image file. These class specs and method specs are also materialized when loading libraries. In order to build a Smalltalk model for everything that will be part of our new image, we need to describe the graph of objects it will include. For each of these objects, we need to store some information that is usually hidden by the VM in the running system, but that is essential if we are to save a new Smalltalk image that can later be run. For this, we create a foreign object for each object that will be created in the new image, and an object graph is built with them. There are many kinds of foreign objects. This reflects the fact that some objects have instance variables, while others have indexes floats like arrays. Still, other objects are made of bytes or other numeric values, and yet others have their value encoded in pointers to it, like small integers, and hold no state at all. These are the foreign object classes used to model regular Smalltalk objects. Each of them knows how to create a real object of its kind when serializing the object file. As you can see, a located object holds the pointer in memory where the real object will reside in the new image, and the identity hash it will use. Immediate foreign objects has neither, because immediate objects don't use memory as they are encoded in the very pointers referring to them. This means that creating these foreign objects and creating the object graph is also allocating memory in the new image. The moment that memory is allocated and pointers are assigned to you is when we build this graph. Also, these foreign objects form a linked list in the order in which they were allocated. And that is also the order in which they will be saved and stored in the memory of the new image and saved in the image file. These are the foreign objects used to create Smalltalk code entities in the new image. The represented object that is held in the represented object instance variable will not be a class of a method, but an instance of new classes called class spec and method spec. These foreign objects will create the real classes and methods when serialized into a new image. The most important ones here are those for classes, metaclasses, and compiled methods. We also build foreign objects for method dictionaries. These foreign objects form the meta model of the new Smalltalk image. The object graph they form is not unlike that of existing classes and metaclasses and method dictionaries and compiled methods, but they form a completely separate object graph. Besides, as they will be used for serializing them into a new image file and not for running them in the current image and VM, the services they provide are completely different to those of behaviors and compiled methods. So these are not classes and methods. We want to build a new image that includes essentially Smalltalk code, right? We could think that our existing Smalltalk image already includes a model for Smalltalk code. And that is true, but we don't need or want to be able to run this new code in our old image. Bootstrap includes a new object model for Smalltalk code that is completely separated and independent of the existing classes and methods of the image that runs the Bootstrap tool. The model for the code in the new image is not a set of classes and compiled methods, but a set of class specs and method specs. This includes all the required information to be later materialized as class and methods in a running system, but they are not part of the host image meta model. This means that the classes and methods that will be included in the new Smalltalk image we're building don't need to resemble those in our existing system. We could even model new kinds of classes, not only those supported by our host VM. For instance, it's trivial to model immediate floats or characters in a system that doesn't support them. This feature could have made the migration of Squeak and Cuis to closures and Spur much easier and less hacky in the past if we had something like this. Additionally, references from these objects are controlled carefully, so there's no risk of unwanted objects leaking into the new image. In order to turn this object graph into a new Smalltalk image comprised of the real objects we want, we need an image builder. The main purpose of an image builder is to traverse a collection of foreign objects, and for each of them write the bits for the object header, and then write the outward pointers or literal bytes for the object contents. Format-specific image builders also know how to build format-specific internal data structures, usually only known by the VM, but that they need to be there, the image file header, and some other internal details. Currently, we have image builders for 32 and 64-bit Spur image formats. I wrote originally also a reasonably complete V3 image builder, but later we removed support for V3 images for Cuis, so this was abandoned. The new images could be very different from our existing image. Not only it will include different set of classes and methods, but it could even run on a VM with different execution semantics. This means that we cannot run any code that belongs in the new image until it is built, saved to disk, and run by itself on its appropriate VM. Trying to run such code in the host image, in the builder image, is not safe and maybe not possible. So this means that we cannot run any of that code inside our tool. We might not even have execution semantics for doing so. It also means that we can't create arbitrary objects for the new image in our build tool because the build tool runs in the old image and doesn't include those classes. Only objects whose class shape and semantics is known to the image builder can be created in the builder image. Because of all this, by default, image builder tools will only create a few specific kinds of objects. These are the objects for code, classes, metaclasses, compiled method, method dictionary, system dictionary, and basic literals. The only other objects we are creating are, besides literals, a few special objects like the Smalltalk system dictionary, the symbol table, the processor, and very few other objects that are required by the VM to run and that the image builder knows how to build. Any other object, for example, additional globals and class variables, must be created in the new image by code included as part of the new image, and only when the new image is run by itself. This may seem a bit restrictive, but is needed if we want the new image to be fully specified only by source code. In any case, the image builder can be extended with new specially pre-built objects if really needed. So what about dynamic libraries? Dynamic libraries reuse much of the model built for Bootstrap. A dynamic library is essentially a collection of class specs and method specs. Still, they are specific to an image format because the image loading the library is not required to include a compiler or to know how to compute the internal state for new classes. Each class spec specifies the shape of a class as known by the builder image, and is assumed when building the bytecode for the method specs. It is important to include the parent class path up to the hierarchy root, because this is a way to completely specify the shape of the instances and the bytecode for accessing instance variables. There is no special file format for dynamic libraries. Library files are just reference stream serialization of the dynamic library object we just described. And any object serialized could be used instead. So loading dynamic libraries. Loading a dynamic library involves several steps. After loading the file and deserializing the objects, we need to run some validations. For instance, we require that every class spec included in the library that also exists in the system that is loading the library has the same parent. This applies recursively up to the hierarchy root. So the shape of the hierarchies, the form of the hierarchy needs to be the same. But the shape of the classes are not required to be the same. A class spec can add new instance variables and is not required to include all the instance variables in the existing class. Both adding instance variables and ignoring existing variables is okay. So if a library adds some instance variables to a class, all instance variables in subclasses are moved to the right as new variables are added before them. Any existing method in the image that accesses these instance variables needs to be adjusted for this. Additionally, if the image loading a library includes instance variables that the library is unaware of, any method spec accessing an instance variable that is now at a different position will also be fixed. After we do this, class initialization is performed, and we are essentially done loading the library. The Bootstrap framework is designed with all the ideas stated before, and it's hopefully easy to extend, but so far we have only been using the existing Cuis compiler, and that means that right now we cannot change language semantics. Enabling that will require pluggable compilers that generate different formats of compiled method and bytecode, or enough information to materialize this compiled method in some way. Right now we are only using the regular Cuis compiler, the standard v3 bytecode set, and we only have builders for the Spur image formats. The knowledge of the details of the Spur image format is well localized in the design, and supporting additional image format is mostly writing a new builder for them. Also, as of today, class spec and image specs are created from existing classes and methods in the system. Complete separation of the contents of the new image and its own source code files requires these pluggable compilers and some additional work. The framework is designed to enable all that, and this is just the first iteration. So future work includes actually writing the missing parts, this separate Smalltalk compiler that can compile source code straight into class specs and method specs without going through classes and compile methods, and without installing those in the system, and ideally using any desired bytecode set. Other ways to specify code to be included are also possible. For instance, a list of code packages or code libraries to be preloaded in the bootstrapped image. This future works also includes writing image builders for supporting additional image formats and VMs, and most likely new kinds of foreign objects to create whatever new kinds of objects those new VMs will support. Compiled libraries are not usable as a means to deploy parts of a standalone application written in Cuis, but there is significant conceptual overlap with code packages, so integration with them makes sense. As part of this, compiled libraries could also include optional source code for use by developers. So we can see all this in action. I will, in order to do this, I guess I need to unshare this screen and share a different one. So let me see how I will do that.
I think it should be possible.
It should be possible. It's just that I don't know how. When I share my screen, the bottom line in Zoom sort of, oh, here it is. Yes, apologies. Stop share. Okay. So now I will share a little bit a quiz window that has all this stuff already loaded. Hopefully you can see a quiz window on the screen.
Yep.
So this is the image builder hierarchy, and here we have the foreign object hierarchy too, the one I just showed you on the slide. Okay, and something we can do is to bootstrap an image and see how that works. So we have several sample images that can be bootstrapped. This is the simplest one. It's called example 01, okay? And let me show you the code that builds this image. So the first thing we do is this image builder has the state required to build an image. So it includes, this is the linked list of foreign objects, first foreign object and last foreign object. It also has enough information to allocate memory, to assign hashes, and to do all those kind of things. Global variables, symbols, etc. So when this object is created, it is created empty, and the first thing to do is to add these fundamental objects and classes that are objects and classes that are required by the VM to run. Okay, so the first object in at least in the Spur object memory, the first object that appear in an image are nil, false, and true with these hash values. Okay, and they are instances of these classes. Okay, then we have these Spur hidden tables that are only for Spur. That is a free list table and a class table. These are internal and only known by the VM, but an image file needs to include them to be valid. Then we have the special object arrays, and then we have some classes that the VM knows about. So any sane Spur image should include these classes because the VM needs to know about them. And
do you mind if I ask you a question at this point?
Yes.
So
sure.
We're creating this image. Now, when we're doing the creating, are we writing octets out to a disk and the image will later be started with a VM? Or are we writing these octets into memory and we're going to put a VM underneath that memory? So it's going to start hot sort of thing. Oh, right. Okay.
This saves, perhaps I should go quicker so we get to that point. Yes, it saves a file. So we have these fundamental classes that are absolutely required for the VM or they will crash, and all their super classes, because to have a assigned class hierarchy, then we have some globals. These globals are also known by the VM. And now that we have all these objects, we can fill the special object array. So this is the minimum set of objects and classes that are needed. This basic method and referenced classes are a set of methods that they are not mandatory, absolutely mandatory, but usually you will want to have them. For example, is nil and not nil and that kind of things. Okay, so it's not a large list. And this is code that is usually required. So if you are building a different image and you want to tweak the contents, you can add or remove stuff from here, okay? And this example, example 01, has a startup method. This is what will be run when the image starts. So here it is bootstrapped example 01 standard output. And this method that will be run when the image runs does this. It asks for standard output and says, hello world, does a little math and exit to the operating system. And that's it. This adds another extra stuff that is required. I will not go into detail here because it may be too much fine-grained, but there are a few extra details in there. This builds all the method dictionaries, and this at the start process. So if we build this and then tell it to save the image, okay, save image does the actual serialization. It streams to a byte array in memory with all the objects. This is the last of the object memory, and then it writes the object header, the image header. The image header goes at the beginning, but it's written at the end because it requires information that is only known when serializing everything. And then everything is saved to a file, and that's it. So if we evaluate this, the result is a new file in my file system that is called example01 standard output.image that is less than 150 kilobytes. Okay. In order to run this, I will need to unshare Cuis and share an operating system command line. So let me generate the other examples, and then we will run all of them. This example 02 is very similar. The interesting part is that before doing what the other one did, it says Smalltalk Zork, okay? And this will give a does not understand error because that method is not included in the generated image. This other example adds support for floating point. It adds all these floating point methods, okay? And the startup method does a little example of floating point math and prints it on standard output. There are further experiments that, well, maybe we'll see them later. Let me share an operating system prompt. Here it is. So share this. Okay, so now you see this is very small. I will make it smaller so text should get bigger for you. How does that look? Can you read the command line in there, the text?
Yeah, perfect.
Okay, great. So if I run the first example 01 standard output, this is what I get. Okay, this is a warning by the VM. Ignore it. It gives it all the time running any kind of Cuis or Squeak image. It is for a Mac OS feature that the VM is not taking advantage of. It's completely relevant. So the actual output of the program is hello world. This is bootstrapped Cuis, and 3 + 4 is 7. And this was run by that small 150 kilobyte image. So now if we run the example 02, does not understand, this is what we get. Let me make it easier to see where this starts. Okay, there it is. The same warning as before. Hello world, this is bootstrapped Cuis. 3 + 4 is 7. Message not understand, SORK, and a call stack. The call stack has only one level because it was the first method in the stack that sent the missing message. So this is extremely important. Before I got to this point, each missing method in the image would require like 15 minutes to understand what was going on. After I had this, then if a method was missing, it was trivial to just add it. So it is so much more comfortable to work with this. Then example 03, that's this. Okay, it does a little floating point mixed actually arithmetic between a floating point and an integer. The result is a floating point, and the print string of floating point is also working. So these are all the example files I have. The example 01 is less than 150 kilobytes. Does not understand is essentially the same. Floating points add a little more bytes to there. There is also an experiment to play with files and symbols. This is interesting. Because it tests that the symbol table works correctly. So this creates one as a string, the string with one character that is the ASCII code for number 1, and it looks in the symbol table, so the string 1 does not exist as a symbol, then it tries to create it. This is a result of the creation of the symbol, and then if we do a lookup for it, it exists and it's there. So this tests that at least one example of the symbol table works. And the other examples are try loading a dynamic library. I'm not really sure if I have the dynamic library built at hand. I haven't run this in a while, so let's see if it works. No, it could not find file DCL example 03 DCL. Okay, so this didn't work. So the error we get is that binary contents of throws an error with the description could not read this file. Okay, so it's a quite reasonable error message. So let me look for that file. I should have it somewhere, hopefully. Yes, I believe they should be here. This perhaps just works. Yeah, there it is. So if I run this in another directory where that missing file is present, we ask, do we include the library? No. Try to load it. Do we include the library? Yes. So then it tries to create an instance of a class defining the library and computes some stuff and gets this result 1, 2, 3, and that's all. So let me show you the code for this. So what you are just seeing there makes any sense at all, of course. Otherwise, it won't make any sense. If you don't see the code that is running this. So the symbol experiment is this. Okay, this builds the image, very similar to the other one. The startup method is this. And this one, what it does is to look for start an accumulator and iterate and look for one number that doesn't exist as a symbol. This is really complicated and not really needed. It was part of the experiment I was doing at that time, but this code runs in the Bootstrap image. And this, in this case, builds the string with the character ASCII for 1. And so we look up in the symbol table for it. It didn't exist, as you saw before. So we print that, whether it exists or not, the message, okay? And then we will attempt to create it. And then we do to the same variable as symbol, and then we take the result and print that. And if you remember, it was the symbol #1. And now it printed exist, because now doing lookup again in the symbol table does work. So that's this example is very simple, but it proves that the image works. And these were the first step I was doing to have bootstrapped image with basic functionality. The last one I did when I did all this was this example 07 that we have just run, that without the file it was looking for, it would fail. And when I run it in a different folder where it was present, it did work. And the bootstrap, the startup method is this. It starts the same as always, and then it asks for this. Does it include a class named morphxx? This is a copy of class morph in Cuis. I just wanted to take any class that had a significant amount of code to test a little bit how it worked. So does Smalltalk include this key? Well, truth is, in the bootstrapped image, same as here, it doesn't, right? There's no class like that. So it prints whether that class is there, and let's see, it says, let's load it. So then it evaluates this. This code is run in the Bootstrap image. So the Bootstrap image includes dynamic Cuis library, read from file named, and it runs. Sorry, I believe that the actual example I showed was 06 and not 07. This is almost the same. Apologies for that. It's this one, and yes, the library we are looking for is DCL example 03.dcl. So we don't include it, and then this class doesn't exist, okay? So Smalltalk does not include, well, class name is a symbol, but let me go right here. It's not present here, it's not present in the bootstrapped image, okay? So it is that, then it tries to load, it asks if it can be installed. This is where validations are done, and then it installs the library. And then when this code was compiled, this class was not here. That's why I'm not referring directly to it in this method. And I say Smalltalk includes key class name, and I print whether it exists or not. And then to create an instance, I don't reference it explicitly because it's not, the class is not there when this code is compiled, and it's not there when this code is run for the first time, or when it's materialized. It cannot be materialized if it has a reference to a missing class. It would be a missing global, but that would be an error. So I simply do Smalltalk at the symbol, the name, and then I ask for this combined message, and this does the computation that printed 1, 2, 3 in the transcript. So I could go into more detail. There are more examples and there are more to be said here, but I guess this is enough for a quick demo and an introduction to what all this is about. So now I will stop sharing my screen. Okay, and that's all. I'm willing to answer questions if you have any.
I have a question.
Sure.
You're running that with like the latest Spur VM and that stuff, right?
Yep.
Is there a much simpler, smaller, slower interpreted only VM that you can run a small image like that against?
Yes, the OpenSmalltalk VM has both a COG and an Pure interpreter versions, and they are there at the OpenSmalltalk repository, and you can just download them or build yourself one for your system.
I haven't looked at the non-Spur ones, but I'm thinking more in terms of the executable size and stuff, because you know, if we're going to run stuff like this, like I run MicroPython on a lot of stuff now, and a lot of embedded stuff, ESP32s and the new Raspberry Pi Pico, the RP2040.
And
MicroPython.
How much memory do you have in those systems? How much RAM?
So MicroPython will run on a Cortex M4 that has 190K of RAM and half a meg or a megabyte of flash.
I don't think you can fit any OpenSmalltalk VM and Smalltalk image in that space.
Yeah,
I guess that you can do something with 4 megabytes of RAM. Perhaps we can do something with 2 or even 1. I don't think you can do much with less than that. But I haven't tried. Okay.
Yeah, well, it's just interesting. I mean, it's MicroPython is kind of like, if you remember Little Smalltalk from way back in the day, that ran on like a 64K machine. You know, these embedded machines are a little bit different, the ones they build now, because they have flash space that you can actually execute code from, and then RAM where you can keep your you know, your heap and stuff. And normally in Smalltalk, those are one and the same, but they don't necessarily have to be in an embedded system. You know, you can take your compiled methods, and like in MicroPython, they take compiled methods and freeze them, which basically produces something they can put in Flash, and then run those bytecodes directly from Flash, and things like that. So I've always been fascinated with the idea of running Smalltalk on really tiny embedded chips. And
I believe that the OpenSmalltalk VM will allocate even the non-code, that is a pure interpreter, non-cheater, even that version of the VM will allocate memory for its own data structures and for every object in the C heap. So to have a different environment where you have different areas of memory for different things, and one of them is the regular C heap and the other one is in Flash, it would require some interesting engineering at
Yeah.
the VM level, right?
Yeah. Okay. That's
This-
kind of
this-
what I thought where things were right now. And I'm not a C programmer, so I have zero interest in doing that myself.
Okay.
But yeah, that's why I use MicroPython now for my low-level embedded stuff, just because
Okay.
I don't like C, but I can still write, do embedded stuff.
So Juan, I've got a question for you. So what was the prompt for doing this work? I mean, were you just sort of one morning in the shower and you thought, oh, this would be a good idea? Or is there an actual business problem that you're trying to solve?
Well, I have been wanting to do this kind of things for a very long time. You know that Cuis was born as a reduction of Squeak. Okay, I started by removing toys, and then I kept removing stuff until what was left was essentially a Smalltalk 80 system, if you wish, with Morphic and all the modern stuff, but only with Smalltalk developer tools. So it came to a point where reducing it further means not having some of the Smalltalk tools, and this makes any kind of development much harder. So it reached the point where we need to come from the other end, and the other end is a small image, an empty image with only the stuff you want to load on it. I have been wanting to do this for a long time, but there were other much more important things or relevant or even more interesting things to do with Cuis in these years. But what happened now is that Labware sees business value on this. To develop a commercial application to customers, it's good to know exactly what you are delivering and to have a delivery platform that doesn't require source code and that can be enhanced with extra functionality. For example, controlling carefully what libraries are loaded, digitally signing them, and that kind of thing that may be relevant for a commercial product. So that's where the push to actually start working on this came from.
Thank you.
I have a question related to this, I think. So you don't have source code for the packages and the image. That means it's basically a delivery mechanism. So for runtimes, you don't need source code. But what about packages you would need for development?
Yeah, well,
So what's your plan for source code?
Cuis has a package format, has had a package format for a bit over 10 years or 12 years or something like that. That is essentially the chunk format from Squeak augmented with an explicit syntax for class definitions. So class definitions are not a do it. So the system can parse and understand a class definition and do stuff with that. So it's a slightly enhanced chunk format that also includes a feature name that the package provides and versions, numbers for doing validations, and requirements for automatically loading required packages. So we have had that for a long time. This so far is completely orthogonal to that, but having source code packages and binary libraries completely orthogonal is bound to give trouble. These two things should be together usually. So integrating them is something that needs to be done. Ideally, and this is something that will require a little bit of low-level work. Right now, Cuis has, as Quick and Smalltalk 80, only two places to look for source code for method. There is a sources file and the changes file. Cuis also has package files change set files, update files, a user changes file, but all those are not referenced from compile method. Compile methods only point to sources and changes. In order to do this and make it work well, I need to modify the pointers in compiled methods and make compiled methods to be able to point to source code in a library source code file. Okay, so loading is instant, but the source code is there, and that will happen. It requires some extra work. My intention with what I showed today, that is the first iteration of this, is to see whether I could actually build a bootstrapped image that works with the VM, that doesn't crash, that is sane, that has all the required stuff, and that can quickly load libraries. Checking that the loading of libraries was really quick is also a business requirement for LabWare, because they may need to deploy a lot of code. So, and this is over 100 times faster than running the compiler, and that's what you would expect if you're not compiling. Okay, so it needs to do the merge of the class shapes, because a library can come with whatever shape for a class it wants, and what we do is to merge that with the existing class shape in the image, and then we need to swizzle a little bit all the compile methods so they point to the right instance variables. But that is quite quick. It doesn't slow down this too much. It's not even close to compiling source code. So it doesn't decompile and compile. Of course, the compiler is not there. It just messes with the bytecodes and the offset and stuff.
Good.
So in decades past, we used to use the system tracer,
Yes.
which required basically parking your brain somewhere for safekeeping, and then suffering in strange and horrible ways. One of the things that I did back in 96 or 7, maybe, that's a bit like what you've just been talking about for handling source code and stuff, was what we called the new compiled method format, where compiled methods were actually split up a bit more structurally than they are now. So there was a bytecode array, a literals array.
Oh, yeah.
A couple of other things probably. For Spur, you could add all the trailer information that gives you breakpoints and stuff in separate objects. And then the other one was a source accessor. And we did some experiments of making it so the source accessor could be the obvious thing that was a pointer into a file, or a key into a database, or a pointer into a zip file that meant you knew you had to unzip it when you were fetching it. And well, basically, as soon as you've got that abstraction in, you can store your source code anywhere and anyhow you like. Which would make it easy to do. I think VisualWorks does it these days, of when you load a package of source, the source pointers are into that package file.
Yes.
So it would be trivial.
Actually, they have two files: one with a binary and one with a source. The source is in an array of a lot of source files. For every package has a source file beside the changes in the source, the big sources file. So you have like 100 of pointers to files where the source lives, each one for a package. And
the good news is,
sorry, the indexing is quite interesting, because they use just one number to index the position in the file. It's quite refined and valid for small and really big files. So interesting thing. So they get away with one integer and one pointer to a file.
Okay.
For each method. Yeah.
And the plus side of doing it is that you don't end up with a 66 gigabyte changes file because you've tried loading the blasted package 1,000 times, trying to get it to load right. The downside is that now your development system isn't an image file and a changes file and a stable sources file. It's an image file, a changes file, and 16,000 package files that you've got to carry around, which I found absolutely infuriating last time I had to play with Visualworks. But on the other hand, actually using a database to keep your source chunks in suddenly seems like a much nicer idea as I think about it. I mean, these days, you know, even a Raspberry Pi 2, for goodness sake, can run Postgres tolerably fast with an SSD attached to it. A Pi 5, yeah, no problem. And you know, a modern M3 Apple machine or something, who cares? It's so bloody fast. So maybe it's time to start using text databases instead of simple files for this stuff.
Yeah, those are good ideas. Your comment made me realize I gave a presentation on Bootstrap in the Smalltalks conference in Kilmes this year, and my colleague Felipe gave a presentation on the library stuff. And in my presentation, I went into a bit more detail into something that I didn't mention today, that is the prior art, or the existing approaches to doing this. So before doing all this stuff, I took a good look at System Tracer and Squeak. Okay, and well, System Tracer does something completely different. Squeak was sort of a source of inspiration, but it was also what made me realize that I didn't want to have the classes for the new image as regular classes in the building image, because that creates a lot of complications. So
that was a definite downside of System Tracer.
Squeak wanted me to separate that. The only other systems that I paid attention to are Craig's Spoon, that does something rather different, and Faro Bootstrap, that does something very similar to what I wanted to do. But instead of having full control of the object graph that is being serialized in the new image, they use VM Maker for that, and control the new object memory by remote control via VM Maker. And that greatly limits the level of control that you have over what we are building, and adds an insane amount of complexity. VM Maker is a complex beast with a lot of stuff that has nothing to do with bootstrapping an image. So in the end, I wrote it from scratch. And I think it's not too big. It's less than, I don't know, I believe a couple 100 kilobytes of Smalltalk code. It's not something too complex. And it's easier to extend.
So when you were explaining this, something came to my mind, which may be crazy. And I was imagining that the image building part would be like an orchestration thing, and it would have a recipe for building a number of different images, and it would write each of these different images into shared memory and then fire up a VM underneath each one. So you could fire up a whole series of little tiny images, each of which does a very specific job. And then the builder would go to sleep, and all these images would just keep going along. They never need to save themselves to disk. Why would they? Unless they...
Or you can save them to disk when creating them and run them with a regular VM from disk. That is very fast on today's machines, and those images will never save themselves again later, and they could collaborate to take advantage of multi-core processors or that kind of stuff. Those kind of things would be interesting to play with. In another life, many years ago, I worked for a company where we ran expensive simulations of oil and gas exploration and extraction projects for big oil and gas companies, and these ran really slow. And the way to make them faster that I developed for that project was to fire new Smalltalk images, serialize part of the state, give each image a small subset of data to process, and then gather the results. And it worked well on machines of that time that could have easily 4 or 8 real parallel threads running. Yeah, what you say is totally doable and maybe useful for some applications.
Yeah. Yeah, I mean, Dave Lewis's OS Process plugin for Squeak, for example, can spawn an image so fast that it's just insane. I mean, it's essentially instant.
Yeah, of course, such project would use Dave's work, indeed.
Yeah. It works really, really well. Yeah, but thinking of the VM Maker approach, I was imagining using the kind of stuff you were doing there, and instead of writing stuff to a file, writing it into the memory buffer that VM Maker uses to simulate, and then you can actually run it through with the simulator and debug it while, you know, so if you're in the process of writing a new VM, if you've got working code in the VM Maker simulation framework, then using, you know, any tool that does the kind of stuff you're doing here to write the bytes into the VM Maker simulator's image buffer, you could actually be simultaneously checking your assumptions about the structure you think is better and VM code that's going to handle it, and you could have quite a fun time, I suspect.
Yeah, that will be good to do. VM Maker can simulate the whole VM, so obviously it can create new classes or objects of methods, objects of any kind in its own simulated object memory. It's just that it is very complex. It's not that it's impossible, it's very complex.
Yeah, well, I remember. I wrote quite a bit of it a long time ago, but
it's something I
can remember some of it despite my advanced years.
Something that I have always wanted and I never convinced anybody of doing is to split a little bit VM Maker and extract a plugin maker package with only the slang code generator and enough VM knowledge to be able to build plugins, and not the whole VM, let alone the code sheeter and all that stuff. And that would be useful for people who don't want to build VMs; they only want to build plugins.
Yeah, it kind of did used to be able to do that. Actually, that's how Andreas and I wrote most of the early plugins.
Yeah, well, in Cuis, the vector graphic stuff, I did it in Cuis, but I did it in a very dirty way. I took VM Maker and it's I made it sort of load in Cuis. It's completely broken. Most part of it won't work, but the plugin generating part works perfectly well. So it's like the plugin maker I would like to have, but with a lot of extra broken stuff around.
Yeah, I can see that. It's cool. Yeah, it's kind of a situation where finally you've been taking advantage of the fact that we have machines that are rather bigger than we had back in the days of Xerox PARC and you know, near then history, whereas System Tracer was the only possible way you could do this stuff because you just didn't have enough memory to do anything else.
Exactly. Yeah.
But now you've got, well, I think we're currently running at over 1 million times faster machines.
And you can actually build a Smalltalk object graph to model the new object memory, not just the bytes in a simulated world. An object graph for each part of it. That's an order of magnitude more of memory space, and it works perfectly well.
At least, yes.
Yeah, it's cool.
Yeah. Yeah, it can be hard to really get your head around the astonishing increase in compute performance and memory space that has happened in a career. I mean, it is
also
easily
the fact that you build a descriptive model of all the artifacts in an image, classes, methods, whatever, and you can rudimentarily navigate, right? So you have all the relationships to superclasses and stuff. This makes a big difference because then you're possible to generate pieces and then reorganize them, resort them. do things first which you generated last, or something like this. So
exactly, yeah.
I do that often with all this value stuff, and that makes a whole difference. It's this extra layer, this extra abstraction gives you a lot more freedom, which you couldn't have if you would just go from stream to stream like that. It's very cool.
Exactly, yeah.
So Juan, you've got this baby Cuis image running now, doing little tiny things like adding two numbers together. Could it then, I mean, it may be an insane thing to want to do, but could it then load the compiler and then bring in other code?
That could perhaps be the next step. It's not a problem, okay? It's what requires some work. What requires some work is that a lot of code in the image assumes that there is a static state that was saved from last image saved, okay? So a code that needs to be loaded from, to enable code to be loaded from a library instead of being part of the image from the start, the class state and any other static state needs to be lazy, or there needs to be some way to initialize it. Okay, so what I would like to do at some point, and I'm sure I will be able to do it, is to have Morphic be a library that you can have a headless image that now loads Morphic, but Morphic has a lot of static state all over the place. And actually, to build these very small images, I had to work a bit on the static state of character, for instance. I did this in V3 when we still had the old character with a lot of static state, and some other, the floating point constants, for instance. All those kind of things that were not lazy, they were assumed to be there essentially and could be recreated, but the image would require them to be there from the start. I have to refactor and untangle a little bit the code so that that kind of state could be made lazy. And that kind of work is not hard, it's not difficult, but it will be needed to be done for most significant bodies of code that you want to turn into libraries.
No, I was quite along those lines. So I was surprised when you were showing the examples. So symbol table, the table of symbols. So if you're building a new image, you don't have any symbol table. So that's why you were doing. No, you were building up one on the fly.
Yes. The symbol table is built by the image builder. So it's actually built in the old image. But it could be made lazy too, because the example 05 is symbols. So I have been doing other examples, like the does not understand the floating point, some file experiments without a symbol table. So as long as the code doesn't create a symbol, and any symbols are literals in compiled methods, you can get away without a symbol table.
Yeah, that's what
that's
I was
interesting.
Thinking. So how you do that? Because you have message lookup, and so you need a symbol to do that.
You have a symbol, but you don't have a symbol table. You cannot look up for a symbol. You cannot do string as symbol. All the symbols are already there in method literals or referencing from bytecode. They are in the compiled method here, and it works. You only need the symbol table to create new symbols on the fly.
So the method lookup works because the symbols do have a hash and
exactly.
They can be compared.
Right? Yeah. So class symbol is there, they have a hash, they can be serialized and saved in the new image by the builder, but you don't have a symbol table, and it still works. Actually, you can do something more radical than that. You can take a working Smalltalk system and replace all symbols by their identity hashes or some other integer, and the system keeps working.
Yeah, I remember, I don't know if this is what John was mentioning, but there was an attempt to run a Smalltalk in the Palm pilots, where it remove all the symbols, convert it to integers and things like that. So to make it everything small.
I used there was a PDA that somebody had built. I don't know who, but Yoshiki had built a VM, a Squeak VM that ran on it way back in the late 90s. And I was using that in one of my submersibles, running a really stripped down Squeak image.
Cool. And the other thing I noticed, one is so with when you were building, so the nil, true, and false, you assign those hashes 1, 0, 1, 2. So is the virtual machine expecting to be those hashes? So that nil is 1.
The OpenSmalltalk VM expects those hashes to be 1, 2, and 3, I think, or 0, 1, and 2. I'm not sure. Yeah. But those... so I have services for creating objects with newly allocated identity hashes using the same algorithm that the VM uses to allocate new identity hashes, or with explicit ones. And I believe the only ones with explicit ones are those 3 objects.
So those are not immediate objects; they are just allocated in the heap, like any other, but they are just special because
they are just special because the OOP to them is, I believe, in the special object arrays, so the VM knows about it and uses it all the time. So they are special in that way, but they are regular objects. Yes.
Right.
So Juan, it seems to me that
character used to be.
So I was going to say, it seems to me that the pain you describe of bringing bits of the full-blown Cuis into the baby Cuis, because it doesn't have all the legacy variables kicking around, is actually a kind of a good pain, because it's an opportunity to clean these things up for the first time. All those mystery things lurking in the old images can actually be tidied up, and you know for sure that they aren't there.
Exactly. When we get to the point where the full Cuis image is bootstrapped into a hopefully very small one and then loaded as libraries, the quality of all the content in the image will be much higher, because we will know each bit and why it is there. Yeah.
And the other thing I was going to ask, so it's like the objects that you're generating, that there was some reference to the memory. So do you need to worry about the memory layout or where they are located, each of the objects that you're creating in the...
Well, there are perhaps 3, maybe 3 areas in the image file, and this is specific to the Spur OpenSmalltalk systems, right? There is an image header that is, I believe, about 128 kilobytes, that has some stuff that needs to be there, a couple of class tables made as a tree of pages, and some, not too many, maybe 20 slots in the image header that have specific meanings that tell the VM how to find the rest of the stuff, okay? And then we have the regular heap where most objects are allocated, and the only requirement there is that each object has its own room with no one else stepping on it. So what I did is to do a sequential allocation of the objects. And the allocator fetch actually assigns an OOP, a pointer to them. It starts from the beginning of the heap, and for each object that it is required to allocate, it gives the next free byte as its pointer, and then increments that by the size of that object and prepare the headers and all the stuff.
You are basically creating an object graph for the new image.
An object?
Graph. An object graph. Graph.
Yes, an object. Yes, of course. The foreign object is the object graph running in the builder image. So it's an object graph that represents everything that will be allocated that will be stored in the new image. It's already allocated because it has object pointers, and when that is serialized, all the references between there is a dictionary of foreign objects, and all the references to to foreign objects are replaced by the actual loop when serializing to disk or to that byte array. Yeah.
So when you're building this object graph, let's say that you have a very simple A and two children, B and C. So that's your new image that you want to create.
Yeah.
And so object A needs to point to B and C.
Yes.
So how do you manage that? That's a bit. You mentioned that there's some memory allocation in the middle. So are those referencing directly,
yes,
or
we have a set of 3 foreign objects. Foreign objects, regular foreign objects. There are several kinds of foreign objects. Regular foreign objects have a instance variable that is referenced object. So we will have usually, because this could change if the images are very different from the one you are creating. But if you are not morphing any object at all, then you will have a root foreign object whose referenced object is A, and it holds the size in bytes for A, and up to memory position, let's call it 0. Okay, and then that points to a next foreign object because it's a linked list, and the next foreign object will have pointer, I don't know, 16 or 24, whatever the space for A was needed, and that second foreign object will point to object B, and we'll have this up and an identity hash freshly assigned, and same for C. So and this is serialized, the builder iterates over the linked list, and when it finds the first foreign object, it will fetch the referenced object A, and will look for it in an identity dictionary. Actually, in this case, in the first case, it doesn't matter. Let's say we are already saving the bits for object A, okay, the outward pointer for object A in the new image. Then it has a reference to object B from and then it goes into the identity dictionary to look which is the foreign object for object B. And then it queries that foreign object for the identity hash and the size and the up, and serializes that. So you could have a graph of regular objects that are added to that dictionary, and when the foreign object to one of them is iterated, it will go to the dictionary to fetch the following foreign object to get the bits that needs to be saved in the new image. It works something like that.
So I get that
it's harder to say than to actually look at the code. If you look at the code, it's not so difficult.
But
it
it's like
makes sense.
Yeah, it's like you're modeling what actually happens in the memory. So we have direct pointers. So A has a pointer to B, kind of directly in memory. There is no an object table. That's what I'm.
There is not an object table. There is an object dictionary to fetch for each object the foreign object, but this is done for regular objects, and there are very few regular objects. Usually a bootstrapped image doesn't include a regular object. And for other objects, for example, system dictionaries, Smalltalk, globals, is done completely different, because there is an instance variable with the globals that need to be saved there, okay, and the builder knows that it will be saving a system dictionary in some format, so it builds it on the fly. So it's completely different. There is specific code for building system dictionary and method dictionaries. Those are the main classes. It's not this generic will serialize anything code that is almost never used for bootstrapping small images in a way. Literals have specific code. These small images I have built don't include Unicode support. They only include byte strings. So literals are rather simple.
Okay, thank you.
There is a special code for saving arrays. Yeah. So it's all MIT. It's designed to be reasonably easy to understand. So go and play with it.
And also to port to other Smalltalks. I mean, we could.
Yeah, this could run in Cuis and easily save images of other flavors. It's completely dialect agnostic, and if you port the code to another Smalltalk, it will work too. Yeah, it uses rather very little of the host system.
Quite cool. Yeah.
Any other questions?
Yeah, Juan, is all this new code on GitHub along with the rest of Cuis, or is it somewhere else?
Yes, it's there. It's
It's all
part
in
of the
there.
main Cuis repo. Yeah, you
Right.
just get Cuis and do feature require bootstrap, and you have it on your image.
Okay, thank you.
Recently, in December, we started a new release process for Cuis. Now we have stable releases and rolling releases. The stable release tries to be stable, not to change much, and to be a bit more controlled. So it includes a small set of packages. It doesn't include all the packages. So to play with this, use the regular rolling release. That is the same repo we have been used for the last 10 years. With Smalltalk VM, and it's there.
Okay. I got another question about the vector graphics. So
okay,
yeah. So in your image,
a bit unrelated, I guess.
Yeah.
But still okay. Why not?
So now Cuis, everything is with vector graphic, even the icons of the windows, the cross, the plus, the minus.
Those are what the icons that are still not in vector graphics are the small icons for the menus, for instance. We need to work a little bit, grab some vector graphics art collection from the web and map them. It can be done. We never give that enough priority. But yes, the window icons are vector graphics and most of the stuff that you see. So that was the question, Francisco.
Yeah, exactly that. Thanks.
Okay, yeah. If you are interested in vector graphics, you should check the vector graphic examples, the morphs. They are called, yeah, sample 01 start, sample 03 smiley, sample 09 clock. Take a look of that code. The sample 01 start, for instance, is a fully functional morph that has a lot of functionality that is non-trivial to do in the other Squeak variants, and it's trivial to do here. So if you fought Borfic in Squeak or Faro, and you see what it is required to do sample or 1 star in Cuis, you will like it.
So those samples are mentioned in the chapter 7, I think, on the Cuis book, or something else? You don't know?
Most likely, I don't remember.
Right, okay.
They are in the image. So you just click on the word new morph from alphabetical list and go to the S, and they are there. And you create one and start playing with it, with the halo, with the stuff, with the menus. All the stuff is there and works.
Cool.
My favorite mini demo was actually I had somebody in, and I wrote a solitaire game, right? And so I showed them the things were live by selecting a morph, which was a column of cards, pulling it out of the game and showing them it still play. And then I enlarged the column of cards. And of course, the cards are all large. And I take the card from the column, and I drop it on the game, and it shrinks down to the size of the morphs in the game. So the card image is the same there. And if I take a card out there and put it in the column, the container knows what the scale is. So it makes the card larger in order to fit in the column.
That's a good
It's a lot
demo.
of fun to play with. You got to, it takes, you can break things, but it's a lot of fun to play with. You ought to do it.
Yeah.
Well, thanks very much for that one. I have to go now, so have fun.
Okay, I'm glad you liked it. Thank you all for watching.
See you, Tim.
Ciao.
Go on then, I'll ask another one. So is all your energy directed at this now, or any other pet Cuis projects that you're working on?
Sorry, can you repeat?
So is this bootstrapping taking all of your energy at the moment, or are there any other Cuis projects you're working on?
Oh, well, it took most of my time during the perhaps second half of last year. Then I've been working quite a bit on the release process, these stable releases, and a new folder structure, because we used to only distribute images, and we have more and more younger people who have never been exposed to Squeak, and they don't feel comfortable with the need to go to fetch a VM from somewhere else and set up their own folder structure to run Cuis. So I reorganized the folder structure in the repos to include VMs for the most common platforms. That is a work in progress yet. And something that I did after that first release that is also, it took a little bit of time, is to deprecate the V3 image format. And deprecating the V3, abandoning the V3 image format, means that now characters can be immediate, okay? And that means that we no longer need or have two different class for characters. We used to have, until a couple of months ago, a character class that was the old character class from 8-bit strings and the old Squeak, and a Unicode code point for new Unicode characters. And what I did was to unify that. So right now we have a single class character that is any Unicode code point that is immediate, and this is only supported in Spur. We abandoned V3, but we still have two classes for strings. String is byte string, Latin alphabet, and Unicode string is internally UTF-8. So getting all this to work well also took a little bit of time. And I expect to keep working on Bootstrap and libraries during this year, but I also will be working a bit on Morphic. There are on vector graphics, there are a few improvements to be made there. So in a few months, I expect to have ready an updated version of the plugin code that can do, for example, dashed lines. Right now, we have dashed lines that I wrote for Dr. Geo, but as the plugin doesn't support them, if a line is dashed, it's thrown in Smalltalk. The slowdown is not too much, but it should go into the plugin, right? And I am also enhancing the nested clipping to arbitrary shapes for morphs. And that will be part of what I will be working on this year. Yeah.
Exciting stuff.
Thank you.
I have another question,
Sure.
which is about when you were loading the dynamic libraries.
Yeah.
So it's about the name. So when you're serializing the classes, do the name of the class is also serialized there, or you can say load me this. So you don't find a class, say loading from this dynamic Cuis library, and the class will be called something else, like morph XX, like you put.
If you're asking if we have a mechanism for remapping class names,
Yeah,
we don't. It could be done if needed. I haven't seen the need for something like that yet. So if you ask if some symbol is present as a key in system dictionary in Smalltalk, it will answer no if the class is not there. Then you load the library and then you ask again, and now the class is there.
yeah. So,
So
but
that's
yeah, that's what's one part of the question. The other is when the class is serialized, it's also the name is also serialized part of the
Yes.
class. Yeah, yeah.
Yes.
Okay, that's it. Thank you.
Actually, that's when you load a library and the class is already in the system, and it does these things of merging the instance variables to have the union of the sets of instance variables in the image and in all the libraries that you are loading. Okay, that's the final result. It uses class names to identify classes. So it's a traditional Smalltalk AT system.
Yeah, okay. And in the case that you're missing a variable, do you provide a block to initialize them? So
No.
No, well, they are nil then.
They will be nil unless you have some lazy accessor in your instances, or you have some class initialization code that does whatever you think is appropriate. It doesn't enforce a mechanism of that, so far at least.
Okay.
This all could grow where needs lead it, right?
Yeah, I think just in Gemstone you have similar situation where change the shape of a class and then have instance migration. So it's a similar situation.
So far, well, actually, so far we are not even doing instance migration. Yeah, sorry for that. What I just said is actually wrong, because to do the merging of class definitions into a new class definition that includes all the stuff, there cannot be instances. So the idea so far it is that this can be used to load libraries during startup.
So you say the classes, you can import classes with more or less instance variables, but you are assuming there won't be any instances of that class.
Exactly.
Okay.
So all the code is fixed, but the writing code to migrate instances is not too difficult either. It just was not part of this first iteration. What was really important is to get methods right, okay, to fix the method. And that also has a couple of small details there that are interesting, because in the OpenSmalltalk VM there are 3 ways to specify bytecode for accessing instance variables with different ranges. So I had to play a little bit with that.
Okay.
Okay, I will try a question. Hi. Did you try or entertain the idea to trim the image further down? For example, when you see that certain messages are not being sent, you could trim that off, even and make the image even smaller.
That is completely unrelated to Bootstrap and dynamic libraries, right?
Yes.
Yes, there is a method in Cuis that called reduce Cuis that actually does that. And I used to play with that. At some point, I used that kind of mechanisms to find stuff that was in use. And when I started from Squeak and wanted to reduce the stuff I needed to understand as much as possible, And right now that method is there. At some point, a regular Cuis image was something like 4 or something like that megabytes. And if you did Smalltalk reduce Cuis, you would end with one that was 2.1 megabytes, something like that. And that will work reasonably well. So you can play with that if you want. I haven't been doing that lately because right now there are methods in Cuis that have no senders, but they are there for a reason. They are there because they make a conceptual sense as part of a class.
Yes.
And even some methods that are not required by the image, but that many packages assume to be there, and they are there too, that kind of thing. So for the base image, for the base Cuis image, we are past that stage. So we're not doing that any much now. Right now, I think that the future evolution of the modularization and reduction of the Cuis image is to split the image in packages and make those packages to be libraries and to make them easy to load. And maybe they will have a couple of unsent methods or not. That's part of the design decisions of the person maintaining that package.
Thank you. And the other one was about how did you achieve it? Maybe you have the recollection of trying something and realizing it was a false step or a misstep.
Oh, all the time.
Yes. Well, did you have do you have recollections of missteps trying to achieve this? Or things you tried and it resulted that they didn't work as you expected?
Well, one obvious thing when you do something like reduce Cuis, you need to perhaps set a list of special selectors you will not remove even if they are unsent, because they may be required by the VM. And some of them are called with perform. There are even some code around that builds an image by concatenating stuff and then do a symbol of that and then perform that. That kind of things are easy to miss with these automatic tools. Then I don't know. I completely refactored Morphic deeply. The hierarchy structures and the instance variables in the basic morph classes are completely different from those on Squeak. So doing that was very tricky many times, and I crashed the image a million times when doing that. And doing a chain set that you can load in an image and changes the shape of such basic classes and doesn't crash the system is a challenge too. So I don't know. Lots of false steps all the time, and that's one of the reasons why I always work with chain sets and updates. And it's important to have all the updates and all the previous steps on GitHub, because when there is a serious mistake, it is easy to go back and bisect on a range of updates to see where something was broken. When something is broken and it's not obvious what it is, many times I need to bisect like 60 or 70 chain sets, loading the first half and the second half, and bisect like that to find which is the chain set that is breaking the stuff, because it's not obvious at all. So for handling those false steps, having GitHub is wonderful. It's a lifesaver. You are safe. You can do whatever you want, and you will not ruin the system forever. You will only break it for a short while.
Juan, thank you very much indeed. It's been most interesting. I'm going to head off. I'll see you again in another presentation, I hope.
Sure. I hope to see you soon too.
Yeah, thank you very much, Juan. It was a very good presentation.
You're most welcome.
almost 2 hours. And
Yeah.
yeah, that's a bit late here.
It was quite something. Well, I hope you enjoyed it and you found it interesting, and to some of you at least, it sparks your curiosity to go playing with the code and maybe fork it, port it, steal parts of it, or do whatever you want with it. It's there for that.
Thank you very much.
Thank you. Well, I have another business meeting in 6 minutes. So if we are done here, I thank you all for your time, and I hope to see you all soon.